In this video I wanted to talk about the nearest neighbor algorithm again, but this time we're going to use a chart instead of a graph. Notice I do have a graph there. I wanted to explain how a chart is related to a graph because for K6 and higher you probably won't draw graphs because it becomes too hard to see what number this edge goes with or what edge goes with the number, so on and so forth. Matter of fact, probably in a video after this I'll attempt to draw K6 and you'll see that it's kind of hard to keep track of all the sides and all the edges when you have K6. And obviously for higher than K6 it would be even harder. So I just wanted to show you how to do the nearest neighbor algorithm for K5 using a chart. Even though it's easy just to use a graph, we'll do it both ways in this video. We'll do the nearest neighbor algorithm starting with A, and then we'll use the graph, and then we'll do it with the chart, just to show you how to use the chart. And then in the next video, we won't have a graph, we'll just have a chart. And it will probably be for at least K6. I think I made up an example that has six vertices, but just uses a chart. Okay, so here's how a chart represents a graph. If you look at the graph, the edge that goes from A to E has weight 50. That means over here, where we have the intersection of A and E, we're going to rate a 50 in here. Also notice you'll see an intersection between A and E here, so 50 goes there. Now, certain squares in this chart are really easy to fill in. A to A, it's just, you can leave it blank or put a dash. We're going to put like an asterisk. B to B, C to C. These don't have any length because A to A is just going from A and staying at A, so there's no length. A to B is 28, so that goes there and here. A to C is 30. A to D is 40. We already did A to E. B to C, 72. B to D, 55. And B to E is 70. So these can go here. C to D, 60. C to E, 32. And then we have D to E, 45. Okay, so we've already done nearest neighbor algorithm using the graph. I'm going to do it again. See if a different color pen will show up. We're going to start at A. So we're at A. So can you see where I'm writing here? We're going to start at A. The first place that we're going to go is we could go to B, which is 28, C 30, D 40, E 50. Well, our nearest neighbor is B, so we're going to go to B. Once we're at B, we could either go to E, D, or C. It looks like our nearest neighbor is D. When we're at D, we could either go to C or E. E is our nearest neighbor. And then we don't have a choice. We have to go to C now because we haven't been there yet. And then you have to go back to where you started. we'll figure out the length of the tour when we do it over here. Okay, so we're going to get the same answer because we're going to do the nearest neighbor starting at A, but we're going to use the chart instead of the graph. But you get the same answer. I just want to show you how to do it. Okay, what happens is we're starting at A, okay? What you're going to do is look across this row for the smallest number. It's 28, which is right here. Okay. Oh, also, since we're starting at A, I can go like this. Okay, we're starting at A. We look across for the smallest number, it's 28, which was B, so we can go like that, B. What you're going to do now is lightly, with a pencil, go like this and go like this. I hope you can see that. When I upload it on YouTube, I'll hopefully check to see that you can see what I just did. You really want to do it lightly for various reasons, mainly so you can still see the numbers. So you want to do it lightly, so I'm not sure if you can see what I did, but if you're wondering why I don't make it more obvious, it's because you're supposed to do it lightly. So like I said, I'll review that. And if you have any questions, come to office hours. Alright, what you do, why you do this, why you cross them off lightly, is so you know to not go back there. Because you can't go back there because we've already been there. Okay, so now we're at B. So you're going to look across this row for the smallest number. Notice that that's part of the reason why we cross these off. We can't, this is the smallest number, but you can't go there because we've already been to A. That's where we have to go at the end, but we can't go there now. The smallest number is 55, which is D. So we're going to write down D, and then we're going to go like this. So we remember not to go back there. Now we're at D. You look for the smallest number that hasn't been crossed out yet, and it's 45, which is the number that's under E. Now we're going to cross that out. Now we're at E. There's only one number that hasn't been crossed out yet. That's 32, because that's the only place we haven't gone yet, which is C. So we've been every place now. Now we have to go back to A. Remember, this is a Hamilton circuit. We're a traveling salesperson. We have to go back to where we started from. It's where all our stuff that we have to sell is. We get our vacuum cleaners, go to all these different cities, sell them, then go back and get more. Or quit. I don't know. I don't know if too many people are traveling salesperson anymore, but these problems are just called traveling salesperson problems. Doesn't actually have to be a traveling salesperson. There's a lot of other jobs where you go places, then come back to where you started, like just a route for what do they call it? Somebody who delivers mail, or an ups driver. So let's figure out how long this tour was. So we went from A to B, which was 28, B to D, which is 55, then D to E, which was 45, then E to C, which was 32, and then C to A, 30. Notice, if you're in, and this is a mistake a lot of people make, if you're doing K5, guess how many numbers you should have down here? 5. And if you're in K6, you should have 6. K4, you should have 4. There's a pattern there. You should have this many numbers to add together. A lot of people forget to add this one on. They forget you have to go back to the beginning. So let's see, we have 83, 128, 160, 190. So our nearest neighbor tour starting at A gives us a route that has a weight of 190. Is that the best route? Probably not. If you use the brute force algorithm to figure out every possible route, there's probably one better than 190. But remember, the brute force algorithm is an inefficient algorithm because it takes so long. Nearest neighbor and repetitive nearest neighbor are called approximate algorithms because they don't necessarily give you the best route, but they give you a pretty good one very quickly. So in my next video, I'm going to just start off with a chart that has 6 different vertices instead of 5. And I'm probably going to try to draw it, but you're going to see why when you have K6 or greater, it's just easier to use a chart. So that'll be my next video. And then I'll probably have a couple more videos today about the last algorithm that we're going to talk about, cheapest link algorithm. And we'll have charts and graphs for that too.